In this video, I'm going to show you how you can use SciFinder to do some literature searching for our class. So when you log into SciFinder, and as a reminder, on Blackboard there is a link as a way that you can register through for SciFinder through Stockton's library. So you want to make sure you've done that first. You log in, you'll open up to a page like this. Usually what I'm going to be doing is I'm going to either be searching for substances or references. When I search for references, I'm really just using this a lot like I would use Google Scholar. So I'm just going to search for different terms. And if I search, say, for ammonia borane dehydrogenation, maybe a topic I'm interested in, and you can see there's other ways you can search, like author name and things like that. But generally, I'm just going to put something in the search bar like that. Ammonia borane dehydrogenation might take a moment to load, and you'll get a bunch of articles. If we look, right, there's over 50,000 results. Okay, so sometimes that will require you to narrow things down a little bit. You can also see that you can sort by relevance, or you can also sort by some other parameters such as publication date, but relevance often makes the most sense. You can also search by filter it by document type. So if I just want journal articles, and these are some ways you can narrow things down a little bit. Maybe I only want it to be in English. And so that'll narrow things down, but still over 25,000 results. So maybe I'm curious about ruthenium catalyzed ammonia borane dehydrogenation. So you can either search within results and you can type in ruthenium here, or you could just research, right? And I think honestly, that's probably what I do most frequently. So I can write ruthenium ammonia borane dehydrogenation. Okay, so now looks like we're at 11,000 results. It does take away some of these filters that I've put in place. So you could reapply those if you wanted to. But let's say, so you search through this, and maybe this article right here from the Journal of the American Chemical Society from 2011 is what you're interested in. Now you can click on this link here. This is going to open up this page dedicated to the article. Really, that's not even necessary, but you're certainly welcome to try that. The main things that you're going to probably want to do is you might want to pull up the full text. And so we'll do that in a moment. You can also search, see what substances are in there, the reactions. Really old articles, it doesn't have the ability to pull up the actual reactions. You also look up citing articles. So this has been cited 107 times. So you can see what other articles, and sometimes that's a good way to do some research as you find this older article, then you look at what has cited it more recently, and then you can start to see some of the progress that's been made in that research area. I'll quickly go here to substances just so you can see what that looks like. And so it'll pull up every single substance that's referenced in there, and sometimes that can be quite a lot. But maybe there's a substance in that article and you want to do some research about how it was made, so you can use it for that purpose. But what we are generally going to want to do is if I go back here, let's see if it'll load back up again. It might have, let's see here. So for whatever reason, it scrolled all the way down, but we'll come back to the article we were interested in. And I want to get the full text. So what I'm going to do is I'm going to click on full text, get it at Stockton. It's going to pull up our library page. Sometimes this loads a little bit slowly. So eventually it's going to load, and what you should get is something, up there it goes, something like this. Okay, and so if we have access to it, it's going to show you down here. Ideally, if we have access to it, we're going to want to use view online. So I can do that. And if I click on that, it's going to pull up here, and I'm going to be able to look at this article. I can search through it that way. Okay, so that's usually the most useful thing. Sometimes though, if it'll say if it's in a physical location at a library, or if we don't have access to it, if you just click on requests from interlibrary loan, usually the library staff's been very good about that, and I usually get results or within 24 hours or so. Anyway, so you can certainly use that if we don't have online access to it. Okay, so that's how you would search for a topic. And again, you can spend quite a bit of time using more specific search terms depending exactly what you're looking for. But the other place that I like to use in SciFinder is the substances. You can search by substance name, and sometimes that's a useful thing to do if it's a pretty simple compound. Like if I just want to search ammonia borane, that's going to be pretty good about pulling up ammonia borane. Very simple compound. But if it's a more complex substance where the naming is more difficult, or maybe you don't exactly know what you're looking for, you're just sort of looking for a portion of a complex, then the best thing to do is click on draw. Okay, it's going to pull up this. So the drawing here is very similar to other chemical drawing software, whether you're using ChemDraw, ChemSketch, or some other program. And what's nice about this is that you can give it an exact compound, or you can maybe if you have a compound that you're interested in, you can have it pull up something that's similar. So what I'm going to do is I'm going to pull up a compound. And I'm going to use this. This is a cyclopentadienyl ring. Actually, technically, as it's right now, it's cyclopentadiene. But what I'm going to do is I'm going to search a particular compound. Okay, and so I'm using, a lot of times I'll do my drawing with carbon, right? So, and then I'll go through and there's other atoms. I'll add those in later. But so I'm just drawing this. You'll see this is going to be a similar compound to what I showed in the ChemSketch tutorial if you looked at that first by chance. So let's see. I'm going to make this. I can use that to select oxygen. So these are carbonyl ligands or carbon monoxide ligands. I can go down here. I want this to be iodine. And then I want the metal here to be iron. Okay, the bonding there looks a little strange. We'll learn about this more toward the end of the semester, but this is a cyclopentadienyl ring. So the iron is kind of, well, it is bonding to the pi electrons of that ring. So that's one way to draw it, just so that we're showing that it's bonding to the whole entire ring, not just a single carbon, which it can do also. So I had the specific substance. If I hit OK, then I click on search. Okay, what it'll do is it'll do the structure match. Okay, and these are, you want to pay attention here. So as drawn, so if I'm looking for it to be specifically that compound, okay, which it has here, we can do that. Substructure means that it's based around that compound, but there might be some other carbons or other atoms attached to it, so something a little bit larger. You can see an example of that. Let's see, like right here. Okay, so it's got the sort of the framework of that original compound, but it's a little bit more complex. Similarity, as it sounds, is it's looking at similar. So here it's looking at a manganese compound, cobalt compound. It's looking at maybe this iron compound instead of the iodide ligand. It's got the chloride ligand, so it's that sort of thing as well. And you can do all sorts of things. Change this similarity, right? This is something that's probably worth, as you go through this, just to sort of look around and see what you can do. But if you get a compound that you're interested in, you can see that you can search by references. You can pull up all the references. So that's either examples of where people have prepared that compound. Maybe they've used it for something else. You can pull up reactions. And if you want to buy it, you can also pull up suppliers. So references and reactions is probably the most common thing that you're going to want to do. So I'll just go up to reactions for a second. You see there's a lot of results. It's a very common compound. If you're searching for something a little bit less common, obviously you're going to have less results. But one thing I can do is, let's say I want to see how have people prepared this compound, where it's the product. So I can click on substance role, and what it should do is should pull up every example where that compound is the product of a reaction. Okay, and so you can see here, and what it'll do is if there's similar procedures, it'll sort of group them together. But then what you can do is if you find it, you can go to the full text, you can pull up that article. The other thing you can do is you can click on experimental protocols, and sometimes that'll actually give you an idea of the procedure, like right here, without actually having to pull up the full article itself. Okay, so that can be useful. All right, so you might do that. If I go back, I went back a little too far, so I'm gonna go ahead and rerun search and pull that back up again. I can also look at references. And just like with the reactions, right, I can look at the substance role, its preparation, see where it shows up as its preparation, maybe where it's been used as a reactant or reagent. So you can pull up a bunch of different things. Okay. Now, sometimes what you're going to want to do is maybe you are searching, you want a specific ligand, but you don't know what other parts of the complex or the compound are going to be there. So let me show by an example. Um, one of the ligands, let's see, what's an example? I'm going to go ahead and make up a compound. So let's say I am looking and I have this example of a ligand. Okay, and so it's going to bind to the metal like that. Um, Now, if I'm looking specifically for maybe ruthenium complexes with that ligand, I can go through and I can type in ruthenium and I can do that. If I don't know what metal, let's say I just want to see any example of a metal complex, um, there are ways, right, you can use this feature, this X feature, where I can say any metal. You can see there's other examples as well, right? If I want to look at any atom except carbon or hydrogen, any atom except hydrogen, depends on really what you're looking for. But I can do any metal and it'll search that. Okay, so now it'll pull up any metal that has that ligand attached to it. All right, so let's try that. So we hit OK and we search it. Okay, and you can see that it pulls up a bunch of different substances. Again, you might need to use the as drawn or switch to substructure or similarity. But here's an example of a copper complex, and it pulls up some references there. Here's another example of a copper complex. So let's say this is the complex I'm interested in. Now notice that it's showing the binding through oxygen. If I click on this, maybe to make it a little bit bigger, let's see if it'll go. Right, so it's a little bit different, right? But it's got these aqua or water ligands rather than binding through the nitrogen, it's bonding through the oxygen. And actually, in this case, the ligand is in a neutral form rather than deprotonated. So you can pull that up. There's some things where I could search references like we saw before. I could search the reactions that it's involved in. I could search uh, spectra, if there's any spectra that are available. So there's quite a few things you can do there. So that's a general overview of where you would be using SciFinder. Um, Again, I think when you're using the structure search like that, this is really good for the research project where maybe you know the ligand that you're going to be using, maybe even the metal that you're going to be using, and that might be a good way to start to see what sort of complexes have been made. And it might be the case that you search for something that ligand's never been on that particular metal, but that's where you would use things like the similarity search. And then you might find ligands that have been on that metal that are a little bit more um, or that are similar, and so that could be a place where you can start. I'm not sure if this example is gonna work for us, but like here's an example, right? There's a copper ion with a little bit more complex ligand here. Um, Turns out there's no references there first, so that's not going to help us. But that's the sort of thing you're going to want to do is sort of go through this, search for similar ligands, and then often if it's a similar ligand, it might react similarly to the ligand that we're interested in. So if you have any questions, you of course can reach out. Like I said earlier, the topic search is a lot like Google Scholar, so no problem using Google Scholar instead. But this, of course, is going to give you more specific chemistry results.